Properties of the bilateral Laplace transform. The bilateral Laplace transform involves the values of the signal x of t is Laplace transform of this is x of s, and therefore this is equal to bilateral Laplace transform involves the value of the signal for all value of the t, means from minus infinity to infinity, x of t into e raised to power minus st into dt. So the bilateral Laplace transform is well suitable to problem solving involving the non-causal signals. So the properties of linearity, scaling, S-domain shift, convolution and differentiation in the S-domain are identical for both bilateral and unilateral Laplace transforms. And therefore, only the operation associated by these properties may change the reason of the convergence. Only the operations associated with these properties may change the reason of convergence. So let us consider the change in the ROC that may occur. For example, if x of t, the Laplace transform is x of s, and with ROC Rx and y of t is the Laplace transform is y of s with ROC R of y. Then we can write a into x of t plus b into y of t. The Laplace transform is this is equal to a into x of s plus b into y of s with ROC at least Rx intersection with R1. So ROC for a sum of signal is just the intersection of the individual ROCs. So the ROC may be larger than the intersection of individual ROC. If the pole and zero cancels, then in that case a sum of a into x of s plus b into y of s. Then if there is a cancellation of the pole, then we have to also consider the effect of the pole zero cancellation on the ROC. For example, effect of pole zero cancellation on the ROC. So x of t is the signal given, then it's is given like this: x of t is equal to e raised to power minus 2t u of t, and its Laplace transform is x of s is equal to 1 over s plus 2 with ROC here s real part of s is greater than minus 2. And now second is given, suppose y of t is equal to e raised to power minus 2t into u of t minus e raised to power minus 3t into u of t. Its Laplace transform is given, y of s is equal to 1 over s plus 2 s plus 3 with ROC real part of s is greater than minus 2. So here the s plane representation of the ROC is, we can say like this. Is sigma j omega, and therefore there is a, in this case there is a one pole that s is equal to minus 2. So this is a reason of convergence. Second is the like this, sigma j omega, so it is a minus 2 minus 3. So here the region of convergence will be greater than minus 2. Now here the S plane representations, intersection of the ROC is this real part of S is greater than minus 2. However, if you choose, suppose A is equal to 1 and B is equal to minus 1, then we can have like this, x of t minus y of t. So x of t minus y of t. So x of t is 1 over s plus 2 minus y of t is this 1 over s plus 2 s plus 3, and I can also write this s plus 3 minus 1 over s plus 2 s plus 3, and this again I can write s plus 2 by s plus 2 s plus 3. Now here this one pole and 0 get cancelled. One pole s plus 2 and one 0 s plus 2 get cancelled, and therefore what remains, x of t minus y of t is equal to 1 over s plus 3. So the zeros of, so x of s minus y of s, actually this is we are writing the Laplace transform, that is a x of s minus y of s. We are taking the Laplace transform of this. Therefore x of s minus y of s is equal to 1 over s plus 1 after cancellation of 0 and 4. So here the ROC is greater than real part of yes is greater than minus 3. So this is minus 3 and the region of convergence is this. So if the intersection of the ROCs is the empty set, then pole zero cancellation does not occur, and then the bilateral Laplace transform of A into x of t plus b into y of t does not exist. Okay, so this is about the pole zero cancellation on the region of convergence. Next property is the time shift. So x of t minus tau, then Laplace transform of this is e raised to power minus s tau into x of s. Okay, so this is the change in the time shift, and the ROC is unchanged by the time shift. ROC does not change by the time shift. Next is the differentiation in the time domain. d of dt of x of t, its Laplace transform is s into x of s, with ROC for this is at least r of x. So where r of x is the ROC associated with x of s. R of x is associated with x of s. Therefore, differentiation in time corresponds to the multiplication by s. Okay, therefore the ROC associated with s into x of s may be larger than r of x. If x of s has a single pole at s is equal to 0, if this has single pole at x is equal to 0 on the ROC boundary, then the multiplication by s, then corresponding to differentiation, cancel the poles and therefore eliminate the DC component in x of t. So this is the property. Now we'll using the bilateral time shift and differentiation property. We have to solve the example. Find the Laplace transform of x of t is equal to d square of dt square e raised to power minus 7 by 3 t minus 3 by 2 into u of t minus 3 by 2. So by using the bilateral time shift and the differentiation property, find the Laplace transform of this. We know that we first will see this signal e raised to power solution e raised to power minus 7 by 3 into u of t. What is the Laplace transform of this? 1 over s plus 7 by 3. So this is the Laplace transform with ROC real part of s is greater than minus 7 by 3. Now this is the Laplace transform of this function. Now there is a time shifted. This is a t. So e raised to power minus 7 by t. its Laplace transform is 1 over s plus 7 by t. Now there is a time shifted. If the time is shifted, then by using the time shift property we can write e raised to power minus 7 by 3 t minus 3 by 2. Time is shifted by this factor into u of t minus 3 by 2. Therefore, Laplace transform of this we can write 1 over s plus 1 plus 7 by 3 into time is shifted. So here e raised to power minus 3 by 2. Yes, it is Laplace transform. My e raised to power minus 3 by 2. Yes, and here with ROC, that is a real part of s is greater than minus 7 by 3. So this is the Laplace transform of the given function by using the time shift and differentiation property. Now we have to find the d square of dt square. So x of t d square of by dt square is equal to e raised to power minus 7 by 3 t minus 3 by 2 into u of t minus 3 by 2. Its Laplace transform will be, so d square, it is a s square into x of s. X of s we have got this value. So s plus 7 by 3 into e raised to power minus 3 by 2 yes, and with ROC, that is real part of s is greater than minus 7 by 3. So in this way, by the help of the bilateral time shift property and differentiation property, we can find the Laplace transform of this function. So here this is suppose e raised to power minus 7t into ut. Its Laplace transform is this with ROC is greater than minus 7 by 2. But here time is shifted, so we have shifted this time by minus 3 by 2. So u of t minus 2. So its Laplace transform will be 1 over, that is x of s into e raised to power s tau. Okay, so it is shifted by minus 3 by 2. So 1 over s plus 7 by 3 into e raised to power minus 3 by 2 s. With ROC, real part of s is greater than minus 7 by 3. Now x of t is equal to d square by dt square e raised to power minus 7 by 3 t minus 3 by 2 u of t minus 3 by 2. So as this is a square, so here s square by the Laplace transform. So by using this differentiation property, means the differentiation in time domain is s times the x of s. So it is a first order, then it is s second order s square. That's why it is a d square, that is s square by into x of s. So this is x of s. Thank you very much for watching the video.